Okay, good morning, everyone. Today we continue our discussion over sentiment analysis, and we start a new concept, which is market basket analysis. But just before doing that, let's review your second quiz. By the way, the first quiz is under your TA's grading. Hopefully, he submit the grades today or tomorrow. Also, it was so many questions about second quiz, so it's the reason I'm trying to look over their questions now. By the way, at the end, I may drop one of your lowest grades, so let's see. So no worries if you didn't perform well in one or two quizzes. Also, having said that, it might be some similarity between this course and other courses, or sometimes, and the exams are open everything. So if you if you find the answer in other resources, you should consider professionality. Like just follow the university rules. It's pretty much similar with other institutions. If something general, even if something is general knowledge, but if made by other persons and you just use entire text, you should cite their names. You cannot submit multiple times. So if you submit similar question for your other courses, you cannot submit that. It's kind of under self-plagiarism. And these are serious things in higher education, generally in the United States. You can't just Google and see what happens to some people. Even they copy and paste from their own materials. So I don't go to the details of that. Just follow university rules. I think for your orientation, they provided some details. Anyway, so let's go to the problems. Question 1, the problem of creating a decision tree model to classify whether a customer bought high-speed data or not involves supervised learning. The answer is true. It's actually a very basic example of supervised learning. So in supervised learning, you use some algorithm try to predict a label. Label of or your dependent variable. So here, dependent variable is high speed or buying high speed data or not. So we have a label with the two different classes. Any questions for first problem? I just wait a little bit because it's an online class. I cannot see your faces. Then I go to the second question. Okay, second question. What is the purpose of training data set and validation data set? I just put the basic definition. Some of you explain very well, and in your exam, I expect you to just put more textual content here just for grading purposes. So we used a train data set to train an algorithm, have a model, and then we need to validate that model to see how reliable it is. So we need to have a validation or test to check the performance of our model. Question 3, explain discrimination in modeling. Is the type of bias. Provide a reason why it could happen. Provide a solution to reduce chance of having a biased model. Hint, we had the example of biased model in granting credit line to ladies. So a systematic low predicted performance for a subgroup of observations. So we had, for the credit card example, we saw that for females, for female applicants, we had the algorithm didn't give a good amount of credit. It could caused by several issues, such as low observation for the subcategory. Maybe, as I said, when you have when you don't have enough data, don't drop observations. Maybe for female applicants, they drop so many data, so they don't have enough data to train well. So they don't have a good performance, or sometimes you use some algorithms that are not suitable for some applications. Maybe for credit card, they should use better algorithm. There is no mathematic way of doing that. You just need to do it by try and error. And as you might remember in CRISP-DM, which is a standard for data mining, we develop a project through a cycle. The reason that we might have a cycle because sometimes you do prediction and you're not satisfied, so you go back and you change some parts. These parts could be using imputation or using different algorithm. For example, if you're not happy with the result of decision tree, maybe you can just simply use neural network or other algorithms. But again, the answers that I put it here is for grading. So when you want to answer your exams, you need to provide more explanations. What you see here is just a bare minimum for grading. So again, I am pretty sure during COVID, which like most of your instructors are very nice in grading. So, but you just should do your best in explaining your thought process. Any questions? We wait for a little bit, then I go to the next one. Okay, next question. What is overfitting problem in machine learning? It just means your algorithm is very well in predicting the train set, but you can, in the test set or validation set, you have really low predictive performance. It might cause by several reasons, like you use too many variables, or some of your variables are not helpful. Or maybe use a very sophisticated algorithm that are not suitable for your case. In some cases, especially when you have too many dummy or indicator variables, usually in those cases, using a simple algorithm such as logistic regression, which is very simple and very fast, is much better than using sophisticated algorithms such as deep learning. So having a very sophisticated deep learning algorithm with so many hidden layers is not always good. So what can you do? There is something that you can do, like countermeasures. Maybe if you have too many variables or under useful variables, you can do like probably try feature selection. So you select the features that are more useful, or try different algorithms like neural network, decision tree, logistic regression, you name it. There's so many other algorithms. For each question, I wait 1 minute to see if there's any questions that I go to the next. Question 5. Consider figure 4.8 and table 4.1 in your textbook. Is it possible to have a very high sensitivity, a very low specificity, but a relatively high accuracy for a given predictive problem? If your answer is yes, provide the reason. If your answer is no, provide the reason. So for the reasons, I just said maybe you can use a numerical example. So usually when you have too much observation in one category, let's say positive category, but you have low observation for the other category, which is negative here, you might see a high sensitivity but low specificity. Like here, out of actual 508 positive cases, they could predict 500 of them correctly. So the predicted positive while positive or true positive is 500. For the negative cases, we just have 7 actual negative 5 and 2. Out of 7, predicted 2 of them correctly. So a specificity or true negative rate is 2 divided by 7, it's just 28%. And the accuracy is just, sorry, here is a typo, true prediction rate. True prediction rate is true negative plus true positive, 500 plus 2 divided by overall, which is summation of 505 plus 2 plus 8, 515. So the accuracy is 97.5%. As you see, accuracy is very high, sensitivity is high, but we have a very low specificity. I really like one of your friends' answers in his or her, submission. Your classmate talked about medical cases. So in medical cases, we expect most of people are healthy, just few issues. So your mother, if you use such a case, maybe you are very good in predicting positive cases, but medical case usually is opposite. So in medical, basically positive means not means you have problem, but negative means you don't. So in medical cases, usually you have too many negative, just few positive. So probably your mother is very bad in predictive positive cases, but you are good in negative cases. One of the things that you can do is sample, easily sampling, which hopefully if you have time, I'll show you how to avoid such an issue. So there is some specific ways that you can avoid having low sensitivity or low specificity. And then we want to be good in predicting both cases. So hopefully later you see in the workflow how to avoid such an issue. So our goal basically is out of your exam, but our goal is high accuracy, high sensitivity, and high specificity. AUC or area under the curve is another way. So usually if you have high AUC, it usually shows that, so let me just go. You have a high sensitivity and a high accuracy. Isn't always the case, but usually having a high AUC, which is arrow under the curve, it means you have both high sensitivity and specificity. So again, if you have a low grade in this exam, no worries. There is always ways that you can boost your final grade. If you show good performance in other exams and assignments, maybe I drop one of your lowest grades. Also, you can be more active in the class group me in the social media. You can share useful information or even ask questions or respond to your friends' questions. So you get some bonus to easily boost your grades. I don't judge you for just one or two low, poor performing assignments or quizzes. Okay, let me wait for your questions if there is any questions from you. You can use your text box to send me questions.
Professor, will the final exam be cumulative?
I haven't decided yet. Even let me think. Even it depends on how you perform in the class. I may or may not make it optional.
Okay. Thank you.
You're welcome. Okay, let's talk about your next assignment. It's assignment 6. Actually, in assignment 6, I want you to write a workflow for your final project. You can do it either through KNIME, or you can simply use a piece of paper and draw the workflow. So I don't expect that your workflow is executable. I just want to see if you understand what you're supposed to do. For some part of KNIME, you may just, when you drag and drop new components from internet, maybe you need to update your KNIME or install some packages. But at the end, I just want to see how you understand about the overflow of your project. And also, I expect you try 2 different approaches to improve the predictive performance of your model. Maybe use different algorithms. So if you use different algorithms, maybe you add more branches to your workflow. Maybe in some projects, you need to do feature selection. Actually, if your project is a supervised learning and you have too many variables, maybe feature selection is a good approach. But if it's a not unsupervised learning, you don't have to have feature selection. Maybe you try different algorithms. But at the end, I want to see you try different approaches to improve your predictive performance. And you're not limited to just do 1 or 2 approaches. Maybe you can have different data preparation approaches, or like different type of imputations. So when I say 3 different approaches to improving the predictive performance, it means I expect like you have extra branches, which each branch means you try one way or other way to improve your predictive performance. So again, no worries if you are not very, you haven't encompassed the KNIME. I just want to see, the overall workflow. If you can do through KNIME, you can save your time. But other than that, you can just simply use a piece of paper, draw with pencil, and please take a picture if you draw over a piece of paper, and attach the file in like a Word document or as a PDF. Any questions?
This is due tonight?
April 12th.
Oh, okay. Thank you.
You're welcome. So last week, we started to talk about text analytics applications. You might see we look at sentiments, if it's a positive or negative sentiment. We talk about document classification. And we also had a look at a typical project using KNIME. So I show you a basic KNIME workflow for your final project, which for your final project, again, you have to extend it a lot. For example, trying 2 different ways to improve predictive performance of your final project. For your assignment, you can use that workflow. If you want to do it through KNIME, maybe you can adopt the workflow that I put in the model, just add different branches and try to improve predictive performance. By the way, having said that, you can, the ways that you can boost your final grade. One way is attending the analytical competition this year. So I think the due date is today. So you can just submit your team, your idea, and it doesn't take that much of time. But by participating in that competition, I give you good bonus. And you don't have to win the competition. I just want to see you are active and you're a proactive student and you try to challenge your knowledge. So having said that, please attend the analytical competition this year. It's a really good way of boosting your final grade. Is there anyone from today that attended the competition yet?
You mean registered for the competition?
Yes.
Yes, I registered.
Okay.
Yeah.
Okay, that's good.
Me and Kirti and Kelly we signed up for it.
Yeah, please. I want to see more of you sign up for it. Is at the end, my goal is you understand the class and have a really good grades. Is if you, I don't care if all of you get A in this course, and I wish all of you get a really good grade. One of them is try to be a proactive student. You just means I just want to see you try to challenge yourself. You try to learn. Some ways, one of the easiest way is just signing up for the competition. You challenge your knowledge with other students and see what you end up being. Very good, very impressive that at least some of you are attending, at least sign up for the competition. And 9 is more than enough for the competition. One part is your analytical knowledge, which I think pretty sure with the 9 we can do some great analytical projects. One part is you should learn how to present it well. Maybe Tableau help you to do very beautiful visualizations. And then you should be able to talk about what you did, and you should transfer the knowledge with it. So for this week, please study section 5.2 to 5.6. Is mostly about text analytics, sentiment analysis, application methodology, and demonstrations. Again, for each quiz, I might pick some part of your textbook and consider it for your quiz questions or even for your final exam. On top of text analytics, we also talk about association, rule mining, or market basket analysis. You go over some applications, methodology, and we have some hands-on experiences. I think the previous class, we talked about sentiment. So basically, we have a textual document, which is it's not in the conventional row and columns. We want to get people's opinion, belief, and general sentiment coming from the text. Could be positive or negative sentiments. Is there anyone here can tell me some application of sentiment analysis? So we study a textual document, and at the end we want to get some inference from the textual documents. Can anyone give me good applications for this kind of analytics?
Because if you're wanting to look at, say, consumer trends, there's not going to be just a data set out there, and the spending habits that you can eventually figure out with just actual numbers and stuff is going to take time for that information to be available and also even visible. But if you can see say what's happening on Twitter now about a certain thing, then that's much more pertinent information in a much closer time frame so it's actually useful to apply for other stuff.
Yes, Tobias had a really good example, and he also talked about the reason for that. Yeah, basically customers or general people's idea about the thing first doesn't come in a standard way, or in the structural data frame. So there is, let's say, Apple just launched a product. So people may talk about it. There might be some news about that, and also people may happy or have some issues with the product. So they put in the social media or Amazon review. So what can Apple do? They may hire so many people to talk with the customers and fill out surveys. Is very costly and takes a lot of time. In contrast, you can just make a contract with Twitter, download the tweets are related to your product, and analyze to see if general sentiment is positive or negative. And also, you might remember we talked about predictive analytics in text mining. As you might remember, I said each word could be a variable that you try to predict one outcome. Let's say for Amazon case, you have so many customer reviews and each of them leave 1 star, 2 star, like 3, 4, and so on and so forth. So you can use their words as a variable trying to predict a star. At the end, if you get information sooner, you can basically make a lot of money and just trying to improve your product based on customers' feedback in much faster and much more economical. So instead of, let's say, hiring 1,000 people to do survey, which I'm pretty sure you did survey for some of your class projects before, as you see, it's very time consuming, it's very tedious. Many times people don't answer to your questions or surveys. Instead of that, you can easily run a text mining program, study their feedbacks, and just then see the general people's opinion about your products. In one paper, I've seen that people try to see what are the factors associated to customer review over hotel services. For example, why people give 1 star, 2 star, or for some hotels they give 5 stars. Some is like, for example, the air condition, cleanness, staff behavior. So instead of just stopping by each customer, you can easily get their feedback and try to improve your business. Yeah, application could be like voice of customers, like as we see, many of them related to your customers and market, your brand, financial markets. For example, you can run text mining over Google News, Yahoo Finance News, and see what is going on in each market. For example, let's say you as a human have some limitations. You cannot read Yahoo News, Google News, like other like Associated Press or other news, or there is some news around the world. For example, let's say you might remember in the last couple of weeks we had the issues in the Suez Canal. So it blocked. I mean, the channel was blocked. So it may increase oil price. It might affect other markets. So let's say you have two ways. Maybe one way, just hiring many people to read the news 24/7, or using text mining and automatically reading the news. So let's say if there is a news coming saying that the Suez Channel is opening soon, so at that case, maybe stock of the ship companies would increase. So if you know it like even 20 minutes ahead of time, and maybe if you buy so many ship stock at the time, you make a lot of money in 20 minutes. By knowing the news 20 minutes ahead of other people, you make a lot of money. So let's wait 1 or 2 minutes for your questions to see if you may have some questions or not.
Professor, I have a question.
Sure.
So for sentiment analysis, so probably lots of I mean, like most of data is from internet, like social media or something. How can we get those data?
It's a very good question. Actually, thanks for asking. So one way, let's say for Twitter analysis, so many stock traders have a contract with Twitter. So they just like make an application with Twitter. They pay a lot of money to download the tweets relevant to some certain, let's say, stock hashtags. Some cases, if for Twitter, if I teach you Python in the next year, I teach you how to connect to Twitter. In the last year that I taught, my students learn how to connect to the Twitter. But if you can make a free application with the Twitter and get the data for free, but it's just a limited number of tweets, you cannot get all of it. On top of that, some also companies like Facebook, they sell it, and it's a way that one of the ways that Twitter and Facebook makes money. There's another way which is web scraping. Let me talk web scraping. There is some Python packages like Selenium, Beautiful Soup, or Scrapey, or other packages. So basically, instead of you reading the text documents or news from Yahoo News, Google News, you make some codes to go to those websites and read the news, read the text, and give you some feedbacks. If you haven't done web scraping before, it's actually an easy one. You can find a good tutorials. I think Udemy has a good course for web scraping. At the minimum, you should need to know these two packages, Selenium and Beautiful Soup. So basically, with web scraping, you can download those texts. And so basically, web scraping part is the data gathering section of your data mining project. Then you need to use some packages to convert the textual documents to the numerical equivalent, and the remaining is same. So you have some machine learning algorithms that learn from those numerical equivalents, and you can predict an independent variable.
Okay, so is there any other like applications without using social media, text, or
Yeah, with Selenium and Beautiful Soup, you can make some applications for scraping the data. But again, for more conventional ways, I mean, Twitter or Facebook or similar companies, you can either get the data for free, if the free section is very limited, or you can pay those companies and they give you all the tweets that you want.
Okay, thank you.
You're welcome. Yeah, getting data is very important in such a case. But let's say, let me just get back. So let's say you have an application with Selenium and Beautiful Soup, and you read news about, let's say, some companies or some events. So having positive or negative sentiment may tell you an idea of what could happen next 20 minutes. Having said that, many people claim that most of trades in the stock market is happening through robots, or what they mean robots is just some Python codes. So most of it, or the biggest one, is doing by some softwares that they predict either they should sell or buy, and they automatically sell or buy their stocks.
Professor, going off of the question from before, can we also gather data from different platforms like Twitter and Facebook and put it into one platform to see which one performs the best and to see which one has the best interaction and sentiment?
Yes, actually, yes. It's better to have multiple sources. Yeah, you can have multiple sources, and could be Twitter, could be Facebook, could be news, and you put them together. Some of them might be more useful. Yeah, good question.
Thank you.
Then we talk about sentiment analysis process. So sentiment analysis is very similar to other data mining projects. Just in the first section, you need to convert your textual document to numerical equivalent. One way is just having a dictionary. So in your dictionary, you understand some words are positive and negative. And some characters or some like phrases may not be useful. For example, THE in English doesn't bring any meaning. Maybe you can exclude them, or maybe you can exclude exclamation mark sign, or like you basically you need to refine your text. Is like get rid of some text, finding tagging each part of your text or word as a positive and negative. Maybe at the end you can aggregate summation of them. For example, in the one tweet, if you have 5 negative word but 25 positive, that is mostly this tweet has a positive sentiment. If it has like 20 positive, 20 negative words, it might be more neutral, or like similar cases. Having said that, there is more complex way of finding your sentiment. Some words might be much more negative than other words. For example, sad is negative, but murder is much more negative than sad. Or you can find other, like, for example, winning lottery is probably much more positive than good weather. Anyway, so again, if your focus is not in text mining, that's okay. You just need to know we have some textual documents. We need to refine those textual documents by maybe excluding some words that doesn't bring that much of meaning, then focusing on each word and finding their associated sentiment, either positive or negative, and summing up all of the positive and negative labels, and at the end judging if your textual document has a positive or negative sentiment. Having said that, let's say instead of paragraph, we might have just a tweet. Let's say or maybe Google News. So it could be like a one page of news. So let's say I'm doing a text, I do web scraping, and I read all the news, let's say about Apple, and everybody's saying positive sentiment. So what I see from that, probably Apple stock would increase soon. So I may buy so many Apple stock and wait to make a lot of money later, because it seems everything from Apple has a very positive sentiment. And in the opposite case, if you, let's say you have a contract with Twitter, or anyway, you make a free Twitter app and you download the tweets and all of them are very negative about some stock, maybe you decide to sell them, because negative sentiment is probably associated to losing some stock value. Maybe it's better to sell them now. I think I just talked about it. Okay. Any questions so far? Okay, another data mining basic application is association rule mining. Basically, we want to see which items might go together. One example is when you go to, let's say, Walmart or other large chain stores, You might see some items go together. There is a like traditional example, which is diapers and beers. Can anyone tell me why in some, or I guess majority of supermarkets or superstores, diapers and beers are close to each other? It's probably, there is an association between them.
Because it's generally a grown person, like an adult who's buying diapers for their children, who's also probably tired because they're raising a small child, so they need a drink once the kid's asleep or something like that. So you might as well put it next to each other.
Yeah, yes, your explanation is really nice and it's correct. At the end, if you want to find association, it's very good to explain why there's those association. If you can provide some reason, that's good. But at the end, you look at numerical or objective measures to talk about the association. One, based on what your friend said, yes, an adult might be upset with having too many kids, or at least even one kid, and they need to buy diapers for their baby, but maybe they don't have time to go to have fun at bars, or they are maybe very tired, so they need to sit at home and take care of the baby, and instead of going to the bar, maybe he or she could be a couch potato and just watch Netflix and just drink beers. What other association you might see in like a large supermarket? Is there anyone who can provide an example? What other items you might see in like Walmart that are very close to each other? I think there's a ton of them. Let me give you another example. Maybe like sugar and coffee, or maybe coffee and like coffee filter, right?
Peanut
Or,
butter jelly?
yes, yeah. What's the association between jelly and the butter? Peanut butter and jelly. Could you give me a reason why they could go together?
It's something sweet and savory. So like you put it together and it could be a perfect sandwich to give to your children.
Yes, yeah. For me, is a good way of making a delicious sandwich. So maybe for breakfast, so it might be better to put them together. Or in Amazon, when you buy some items, maybe Amazon, eBay, or other website, they also show something similar or something could be associated. So at the end is the money talks. You want to make more money. So if you're working as a business analyst in Amazon, you want Amazon make more money. So you might think somebody who buy a laptop, maybe they need a mouse, or they might need a antivirus. So you can sell them more. Instead of just leaving your customer by his or herself, they might go to later remember, oh, I need to buy a mouse. Maybe I need to buy an antivirus. And maybe they just Google it and they go to, let's say, the company by itself, or maybe they go to eBay or Google. I think Google and Amazon, Google and Walmart, you can buy from them too. So you get your you might lose some money. So you want to keep your customer busy in your own website or Walmart. Maybe you go to Walmart to buy some grocery, and they think, okay, somebody who's buying bread, maybe they want to buy some sugar or coffee filter. So they put some items that go together next to each other. So for you, when go to Walmart, maybe even you don't remember that you're supposed to buy coffee on top of bread. But when they put the items next to each other, you would be it makes your life much more easier, and also the Walmart makes more money. maybe like you go Walmart and you forget to buy coffee, or you forget to buy like chocolate or meat, and on the way to home you remember, oh my god, I forgot to buy like those products. Maybe you buy it from another store next to you because you don't want to drive back to Walmart. Or maybe if there are, let's say, coffee like filters, when you get home, I remember, oh my god, forget that. So you can order it through Amazon. So as you see, it's a really, actually it's a really easy algorithm you learn now, but at then you could make a lot of money. So the input is the what you sell. So basically, you look at the customer receipts, and from those receipts, we try to find affiliation or correlation between some items, and then maybe you find those correlations. You go to your supermarket or your website, and you change the design. Also in the healthcare, there is some illnesses that goes together. For example, if somebody is obese, they might have issues with like blood sugar or sleep apnea, or even they might be associated to high death due to COVID. So I'm not sure if you registered for vaccination. So they ask you to put your health issue, and they might, because they already have some algorithm in their website. So if they think your illnesses is associated to higher mortality due to COVID, they may put you in the front of the line for vaccination. Or you go to a hospital and let's say you have like immune system issue. So if you have immune system issue, they don't put you next to somebody who has like some virus related illnesses. So they want to make you separated from them. So basically they avoid the spread of deadly diseases for you. Any questions? Okay. We talk about Walmart. Okay, let's talk about basically language of association rule or market basket analysis. The names might be a little strange for you because I'm pretty sure you have seen something similar in your statistical or mathematical courses. These are the language that we use for market basket analysis. And again, your exam is open book, so no worries if you may mix up with other things that you have seen your other courses. So association rule, it just means, and like, let's say A implies B. Let's say beer implies, or sorry, diapers implies beer. So A is antecedent and B is consequent. We have support. It just means union of two items, like probability of A union B. We have confidence of B given A, so confidence of B given A, or confidence of A implies B, which equals support, which means union of that two divided by probability of A. Again, sorry, it might look scary, but at the end you just need to multiply or divide two numbers. So another one is lift is equal confidence of A and B, or confidence of B given A divided by probability of B is equal support divided by probability of A times B, or probability of A union of B divided by probability of A times probability of B. Having said that, if lift is more than one, we can say that there is a significant association between A and B. If less or equal 1, it just means presence of A doesn't have any impact on presence of B. We go over an example. These things makes much more sense, but at the end, we try to find the lift between two items, and if it's more than one, we can go back and change our design. It could be a store design or website design or something else. So X implies Y, bracket S and C. Just S, if whenever you see that, just S means support, it stands for support, and C stands for confidence between X and Y. Here, one example could be laptop and antivirus. So you can from previous sale, you can calculate their support and confidence, and then use those for calculating the lift. Having a lift more than one, you can put them next to each other in your store. Okay, let's go to the example. Okay. Let's look at some transactions. As you see, we have transaction ID, and we have SKUs numbers. SKU number just means the code of item. So the left column is your receipt number. On the right side, you have item numbers. So let's calculate the support of 1, 2, 3, 4. These are my items. So out of 6 transactions that I have, in 3 of them I have 1. So support of 1, let me go back to the formula. So actually, this is for 2 items. When there's just 1 item, support means just probability of A. So you don't have A union B, because we are talking about just 1 item. So support of 1 means 3 out of 6. Support of 2, we have 6, 2 in all of our 6 transactions. So support of 2 is 6 divided by 6, and same for 3 and 4. Let's find support of 1 and 2. Just means union, probability of their union. So out of 6 transactions, in this first transaction, 4th transaction, and 5th one, we have 1 and 2 together. So support of 1 and 2 is just 3 divided by 6. Let's calculate for 2 and 3. Out of these 6 transactions, 2 and 3 happen in the first, second, third, and 5th. So, sorry, in 1, 2, 3, and 5th. So we have 5. I think there's a typo. Let me see. Yes, I should correct it. 2 and 3, 1, 2, 3, 4. No, 4, yeah. Yes, 4 out of 6. 2 and 4, first, second, third, sorry, 4th, 5th, and 6th. So 5 out of 6. Support of 3 items. How many times they happen together? 1 to 4 in the first one, in 4th one, and in the 5th one. So 3 out of 6. So any questions about how to calculate support? I think it's pretty straightforward. You just calculate how many times your items happens, and and then by dividing by all the transaction, you can find their support. By the way, if you are not comfortable by asking questions, maybe you can just send me a text so I can read your text and understand your question. Okay, let's look at confidence of A implies B. So it just means there's support divided by probability of A. So how many times 1 and 2 repeated together? First, fourth, and fifth. So 3. How many times item 1 repeated in the first, fourth, and fifth? So 3 divided by 3 is 6. So confidence of B implies, confidence of 2 implies 1. So how many times 1 and 2 repeated together? Again, first, fourth, and fifth. 3. How many times 2 repeated? In all of them. So confidence of 2 implies 1 is just 3 divided by 6. And you can do same for 1 and 2, 2, 4. 1 and 2 implies 4. 2 and 4 implies 1. And 2 and 4 implies 3. So for the last one, how many times these 3 repeated together? So it's 2, 4, 3. So in the first one, second one, and the fifth one. So 3 divided by, let me see if I don't have any problem. Yes, just this 3. How many times 2 and 4 repeated together? In the first one, second one, fourth one, fifth one, and last one. So 3 divided by 5. Again, no worries if I don't expect you to memorize things. So anytime you can just come back here and see what was the formula. So confidence of P, confidence of probability of B given A is just A implies B and is equals support divided by probability of A. Okay, let's look at the next example. We want to find the lift of the association root between 2 items. Let's say item A and 0. So they could be just some item codes. For example, A could be beer, 0 could be diapers, or vice versa. So for calculating lift, let me go back to formula. You can do probability of union divided by probability of A times probability of B. Here, probability of union, in how many transactions these 2 items happen together? In the first, second, and fourth. 3 out of 7 transactions. What is probability of A? 4 out of 7 transactions. What is probability of 0? 4 out of 7. There's 4 zeros. So the lift of A implies 0 is probability of union divided by probability of each of them. So as you see here, lift is more than 1, 1.3. So there's a high association between A and 0 as 2 item codes. So you can basically go to your store, either is a physical store or online store, and you can redesign. And you can do it actually multiple cycles. Let's say you do a one design, and in next month, you calculate the lift between all the items. So basically, you may calculate lift 1 million times or trillion times because there's so many items in your store. maybe you do lift for 2 items, 3 items, 4 items together. So as you see, you might repeat this rule for millions of times because you look at different combinations of items. And in the practical case, you do you calculate the drift of rule every, let's say, maybe 1 week, 2 weeks, or you might have some periods that you look at your lift and maybe you find a better lift between 2 other items, and maybe in the future there is a low lift between beer and diapers. Maybe you exclude them or just put their location in different places. Anyway, as you see, it might be very practical. Again, no worries for your grades. I mean, 1 or 2 low grades probably don't affect you, and at the end I may drop your lowest grade. Just try hard, and again, for boosting your grade, I highly recommend to at least attend the competition. You don't have to win the analytical competition this year. I just want to see you are trying to improve your knowledge, and that's really good. Okay, that's for today. Any questions? Okay, if there's no question, that's for today. So in the next class, again, I go over another workflow and we have more hands-on experiences. Maybe next to, let's see, let me check your schedule. If it's needed, maybe I put more hands-on experiences. Hopefully we have time. Anyway, thank you very much and have a great rest of the day.
Thank you,
Thank you.
Professor.
Thank you.
Professor.
Thank you, Professor.
Thanks.
Thank you, Professor.
Thank you.